Atoms make up everything. But what makes up atoms? Protons, electrons, and neutrons. There are 118 different kinds of atoms, which are each the smallest part of an element. If we observe elements like gold, carbon, and oxygen, we can see that they have very different properties that don't look or act the same. But why are they so different? Well, it comes down to what's inside their atoms. As you can see here, atoms are made of just 3 types of tiny particles called protons, electrons, and neutrons. And each of these tiny particles does something special. For example, it's the number of protons inside an atom that makes each element different. If we look at the periodic table, the first element, hydrogen, has 1 proton. The second element, helium, has 2 protons. And the third element, lithium, has 3 protons. This goes on all the way up to the 118th element, oganesson, which has, that's right, 118 protons in its nucleus. By the way, the number of protons in an atom is also called its atomic number, which you can see here on the periodic table of elements. Now, electrons are much smaller than protons, and they zip around protons at lightning speed, making up something called an electron cloud around the atom. Electrons do this because they have a negative electrical charge, which always pulls towards the proton's positive electrical charge. This pull between the positive protons and the negative electrons is called the electric force, and it's always there. So whenever a free electron gets close enough to a lonely proton, zap, they'll become part of the same atom. That's why all the elements have the same number of electrons and protons. So why do atoms need neutrons? Well, without neutrons, the electric force will cause the positively charged protons to push each other out of the atom. But there's a stronger force that exists between neutrons and protons, which stops the protons from flying apart. It's called the strong nuclear force, or strong force for short, and it kind of works like glue to hold the nucleus together. If there were no neutrons, everything would simply be hydrogen.